This conference will now be recorded.
Hello guys, again today we'll talk about comparing the bonds as you see from in your PowerPoints. This PowerPoint is about comparing the ionic covalent and metallic bond. Ion type of structure, ionic compound, they have giant ionic lattice, particles in the structure, millions of metal and non-metals, and state temperature or always solid. Covalent compound, as we said before, that there are two types of covalent structures, or simple molecular or giant covalent lattice, which we call as simply macromolecules. There are few non-metal atoms in simple molecule, usually liquid or solids, but liquids or solids or gases. Giant covalent lattice, millions of metal non-metal atoms joining each other, they are at solid state. We are talking about silicon dioxide, graphite, and diamond. Metallic, giant metallic lattice, millions of metal ions join with each other. And example, all of them are at solid state except mercury. You know that mercury is only metal which is at liquid state, but the non-metal which is at liquid state was bromine element, if you remember this easily. So substances with a giant structure generally have high melting and boiling point because all atoms are strongly bound together, forming continuous 3D lattice or structure. There are a large amount of energy needed to break down. In ionic compounds, we have strong electrostatic forces. They are tightly packed to each other, and mostly it's impossible to break down these bonds. You need high temperatures. So strong covalent bonds hold atoms together, like diamond, silicon dioxide. And last one, in metallic bonding, strong metallic bonds hold ions together. Strong metallic bonds hold ions together. So you can practice it at home too. For example, words match each the substance. For example, this structure reminds us the diamond structure. So we know the diamond is giant structure. So it has high melting and boiling points. So ductile, malleable, they are properties of the metal, so you don't need to choose them. So diamond, is it brittle? If you try, yes, we can break down the diamond. We are talking about here physical breakdown, not applying the heat and break down this. Ionic lattice we saw in ionic compound, so you don't need to show it here. Conduct electricity, we say the diamond is pure conductor or insulator of electricity. Ductile, we say denser. Ionic diamond is a denser material, as you know from before. Structure, this structure shows us what? Giant ionic lattice. So again, giant structure, high melting and boiling point. So let's continue. You know the giant ionic lattice or ionic compounds are soluble in water. Just simply remember the salt, which is sodium chloride. It is soluble in water. So they are brittle. When you apply force, they can easily shatter and break down. There we have here giant ionic lattice. Yes, it's structured as giant, but it is ionic lattice because it's made of positive and negative ions. And giant ionic lattice. What about conduct of electricity? Most of the students are missing this part. Ionic compounds conduct electricity, but when they are able to conduct electricity, do not forget that ionic compounds conduct electricity when they are molten or aqueous. Molten means you are applying heat to it and you are making it liquid, L. We are showing molten as L symbol, as you know from before, and aqueous means dissolved in water. But why at aqueous or molten state they conduct electricity? Let's explain this. As I said before, that an ionic compound consists of positive and negative ions. They in a solid state they are tightly packed. At solid state they are tightly packed each other. Let's draw like this: positive and negative. But they are simply they are tightly packed to each other. But when you will start to heat them, because you need this one, you will need for electrolysis topic. When you will start to apply heat or heat this compound, what will happen? It will turn into liquid state, and ions will start to separate from each other, like in liquids. So ions will start to move freely here. So if the ions are moving freely, they can easily conduct electricity. This is molten state or liquid state. But what about the aqueous? Why aqueous ionic compounds conduct electricity? In aqueous ionic compounds means when they dissolve inside the water. Let's say you have sodium plus and chloride ions. Sodium plus and chloride ions. When you will dissolve when you will dissolve sodium chloride inside the water, as you know that H2O, which is water, consists of two ions, hydrogen plus, OH negative. So what will happen here? Hydrogen ions and hydroxide ion will start, or water will start to simply surround the sodium plus and sodium chloride, chloride ions. They will start to surround them. So, but what happens when surround takes place? Here simply, hydrogen is positive ion, hydroxide is negative ion. Hydroxide and hydrogen ion. Hydroxide ion will start to attract sodium ions and take to other sides. They will attract hydroxide ions. And chloride hydrogen ion will start to attract chloride ions. So what will happen here? Simply, the water molecule will simply split the ionic compound into its ions. So the ions will start to move freely, hydrogen plus, OH negative. Ions will start to move freely, so they will conduct electricity. But here, electrical conductivity is not acceptable because we are talking about here at solid state. Ionic compounds are denser, as you see from the other topics. So again, at home you can continue and do the others here too. So complete each statement. This is for you to summarize the topic. Summary activities. In summary activities, we have glossary. Each word, allotrope, for example, structurally different from an element with different physical properties. Covalent bond for giant structures. You can easily practice it at home. You can practice this game. Multiple choices. For example, what's a covalent bond? Covalent bond, shared of pair protons, no. Shared of paired neutrons, no. We are not sharing any proton or neutron in the bonding, but shared of paired electrons here, for example. Again, which of these can form a covalent bond? We say that covalent bond is formed between two nonmetals, so you have to choose nonmetal atoms here. So this is what you have to practice at home. You have to practice at home. So this is about the covalent bonding. This is about the covalent bonding. Now I will show you the metallic bonding on the board. So metallic bonding. So what's metallic bonding? Metallic bonding doesn't take place between two metals. This bonding is different than the other types of bondings. Metallic bonding. This bonding is different than other metals. How is it? Metallic bonding doesn't take place between two metals. For example, between gold, or copper and, for example, silver. That's here silver too. So it doesn't take place between two metals. This bonding is take place inside the metal. How? We know that metals are positively positively charged ions. So when metals lose electron, they make positively charged ions. But when they lose their electrons, these electrons become delocalized. What is delocalized word means here? Delocalized means these electrons will not be associated to this metal. So delocalized electron will just spin or turn around this metal ions. So we will be force attraction between these positive metal ions and their delocalized electrons. We call it C of delocalized electrons, C of delocalized electrons and positive metal ions. And they are positive metal ions. Positive metal ions. So between these positive metal ions and C of delocalized electrons, there will be strong force attraction. Again, it is electrostatic force because this force will take place between positive and negatively charged, positive and negative charge. So there will be force attractions between these delocalized electrons and positive metal ions. So this type of force attractions will be called as electrostatic forces. Why? Because they take place between opposite charged ions. Okay, but what does metallic bond strength depends on? For example, metallic bond strength depends on, firstly, charge of the metal ions, strength of metallic bonding, depends on two things. First, charge of or charge density, let's say charge density or charge on the metal ions on metal ion and their delocalized electrons. Delocalized electrons or free electrons, we call them. Free electrons. Delocalized electrons. How it depends on the delocalized electrons? Let me do them too. How it depends on. So again, there are strong force attractions and electrostatic forces here. Let's say you have sodium plus, magnesium plus 2, and aluminum plus 3. Sodium plus, magnesium plus 2, and aluminum plus 3. All these elements have same number of electrons. We call them isoelectronic, or now you know them. Isoelectronic. But what about the ions? As you see here that sodium has +1 charge. Sodium has +1 charge. Magnesium has +2 charge, and aluminum has +3 charge. What we are talking about here? So when sodium makes one positive sodium ion, sodium will have only one delocalized electron, which it will make a metallic bond. Magnesium, which is +2, will have two delocalized electrons because if it wants to become stable as light noble gas, it has to lose 2 electrons. So between positive magnesium ion and delocalized electron will be metallic bonding. Same thing we will show in aluminium. Aluminium is +3. It will have 3 delocalized electrons around it. These are electrons. So there will be force attraction here. So it is a logic. As you are increasing number of delocalized electrons and the charge, how positive is the charge? There will be strong force attraction. How many delocalized electrons you have? There will be strong force attraction or strong metallic bonding. If you will compare them, metallic bonding strength increases. Bond strength increases. Why it increases? Because charge density increases. Charge density or charge on the metal ion increases, and number of delocalized electrons increases. Number of delocalized electrons increases. So it means how positive your metal ion, its metallic bond strength will be stronger. How many we have delocalized electron? As the number of delocalized electron increases, it will have strong metallic bonding here. Okay, so you know the properties of metals, that metals are good conductors of electricity and heat because they have, as you see, delocalized electrons. Metals are malleable. Metals are ductile. These properties we passed with you. They are malleable, ductile. Metals, they are malleable. Malleable means they can easily bend. They are ductile. They can be drawn into wires like copper. They are sonorous, they are shiny, they are properties you know about the metals. But how the metals become malleable? So let's say that these are positive metal ions. These are positive metal ions, and there are delocalized electrons between them. So when you are applying force to the metal or metallic bond, what happens? These layers start to slide over each other. These layers start to slide over each other. They start to slide over each other. They start to slide over each other. So they will easily become bent. Okay? You are not breaking down them, you are bending them. Okay? This is the difference between ionic compounds and metallic bond. There is a bending here, not breaking down. Okay, this is the end of the metallic bonding. See you in the next lesson.